Hey students, this is lesson 1-2B, slope and scale. In this lesson, you're going to learn how to understand how the change of scale can affect the appearance of the graph of a line. Right now I'm on page 10 in your packet. You can find that. First thing we're going to do is just look at how the scale can change the effect, and then we'll kind of look more closely at how to change the scale on the graph to make those different effects. So let's go ahead and make a table for this equation, y equals 2x plus 1. So we have x and y. Let's do the first 4, 1. So all I'm doing is plugging in these values of x. So to get y is equal to 2 times x plus 1. So in the first one I'm doing 2 times 0 plus 1, which is 1. Now I'm doing 2 times 1 plus 1, which is 3. 2 times 2 plus 1 is 5, and so on. And so these are the points I need to graph. So I'm going to graph them on the first graph here, and I get 0, 1, 1, 3, 2, 5, 3, 7, 4, 9. And if I connect those dots to show all the points that follow that relationship, the line would look something like that. Okay, and notice that that scale of that graph was just goes up by 1 on the x-axis and also up by 1 on the y-axis. Now we're going to graph them on the second graph, same points, 0, 1, 1, 3, 2, 5, 3, 7, 4, 9, etc. And if I connect those with a line, the line looks kind of like that. And notice that even though I'm doing the exact same points on both graphs, that this graph looks much steeper than this one. And it was actually because of the change of scale on the y-axis that caused that. Notice on this y-axis we went up by 2, while on the x-axis we went up by 1. So the scale was 1 on the x-axis, 2 on the y-axis. And that changes the effect of the graph. So we're going to go to the next page and we're going to try a couple of those and see if we can't have some different effects by the scales we choose. Here's the problem. We have Ava's mother thinks Ava is spending too much money on DVDs. Ava says that since DVDs cost only $10 at deep discount sounds, the amount she spends does not increase very quickly. Ava decides to make a graph showing how the total amount spent changes as she buys more DVDs. She thinks that if she chooses her scales carefully, she will convince her mother that the amount increases at a slow rate. Draw a graph that Ava might use. All right, so thinking about what we just did here, if we make this graph right here, and we just go up by 1 on the x-axis down here, and we go up by 10s on the y-axis, the line is actually pretty steep. So I don't think this is going to convince Ava's mom that she's not spending too much. So what Ava would like to do is to draw a graph that's not quite as steep. So remember that on that graph that we just had, we had 100 way up here. So if we graph 10 DVDs bought, that's going to cost $100. So what if we had 100 a little bit lower, like maybe right here instead? And in order to do that, all we need to do is double the scale here. So instead of going up by 10s, I'm now going to go up by 20s. And when I do that, at 10 DVDs, we'll have to have a dot right there. And at 1 DVD, that's $10. 0, 0, 2 is 20, and so on. And what happens is we end up with a lot flatter line. And the effect of that is it looks like she's not spending quite as fast. So Ava's mom is not very happy about that. All right. But Ava's mom knows a little bit about graphing too. She wants to make a graph to convince Ava that the total cost increases quickly as she adds to her DVD collection. So again, this is the graph that we would have if we went up by ones on the x-axis and tens on the y-axis. What Ava's mom is thinking is that, well, maybe if I had, instead of going up by ones here, if I was showing that she spent her $100 a little more quickly, like maybe right here, so that we had 10 DVDs there, and that was $100, I wouldn't need to change the scale on the y-axis. I'm still going up by tens. But on the x-axis, I'm going to just go up by 2 DVDs at a time. And that'll give me my 10 right in the middle here. Okay, so 1 DVD is $10, which is right there. 2 DVDs is 20. 3 DVDs is 30, and so on. And when I do that, what I get is a graph that looks really steep. So then Ava's response to that is so you can have quite an effect. In fact, this strategy is sometimes used by advertisers or politicians or things like that to help convince people that to try and trick them into thinking something's a lot worse than it is, or maybe not as bad as it is. All right, we'll talk more about this next time we meet in class. If you want to try the next problem, see if you think you understand it, go ahead.